All right, so you've made it through class 10 trigonometry. You're probably thinking it's all about sine, cosine, and right angle triangles, right? Well, guess what? That was just the warm up. Today, we're going to dive into what trigonometry is really all about. It's time to level up. So, let's start with something you think you know inside and out, an angle. Seriously, what is an angle? I bet you're picturing, this space between two lines. But what if I told you there's more to it? What if I said that angles have a direction?
Yeah, that's right. So in the world of math, we have a rule. If you turn counterclockwise, the opposite way a clock's hands move, we call that a positive angle. But if you go clockwise, just like a clock, that's a negative angle. So a 30-degree angle and a negative 30-degree angle, they're not the same thing. They're totally different movements.
And that little idea opens up a whole new can of worms. Think about it. For distance, we've got meters, kilometers, even miles, right? So why do we only ever talk about angles in degrees? It's time to break out of that box. I mean, why 360 degrees in a circle? Anyway, it's kind of random, right? Just a number someone picked a long, long time ago. But what if there was another way? A more natural way to measure angles that's baked right into the DNA of the circle itself? Well, there is, and it's all built around a unit called the radian. Now, I know, that word might sound a little scary, a little advanced mathy, but trust me, once you see what it is, you'll realize it's actually super intuitive. So, what in the world is a radian? Imagine you have a circle. Now, take the radius of that circle, the line from the center to the edge. What if you could pick up that line, bend it, and lay it right on the circumference? The angle that piece of arc makes back at the center, that is 1 radian. Look at this right here. It shows it perfectly. When that arc length, which we call L, is exactly the same as the radius R, then the angle at the center, theta, is 1 radian. Boom. That's it. It's a perfect one-to-one link. No arbitrary numbers, just the circle talking to itself. Okay, cool. So we have this new unit, the radian, but what good is it if we can't connect it back to the degrees we've been using our whole lives? We need a way to translate between these two languages, right? And that's where we get to the good stuff, the conversion code. This is the Rosetta Stone for angles.
Okay, let's think about a semicircle, just half a circle. From your geometry classes, you probably remember that the length of that curved edge, the arc, is pi times the radius. So its length is pi r. Now hold on. We just said an arc length of 1r gives us 1 radian. So it makes perfect sense that an arc length of pi times r would give us, pi radians.
And what angle is a semicircle? It's a straight line, right? That's 180 degrees. So, if a semicircle is pi radians and it's 180 degrees, then they must be the same thing. This right here, pi radians equals 180 degrees. This is the golden rule. This is literally all you need to remember. And from that one simple fact, we can cook up 2 easy rules. Want to go from degrees to radians? Just multiply by pi over 180. Need to go back the other way, from radians to degrees? Easy. Just flip that fraction over and multiply by 180 over pi. And check these out. These are like the greatest hits of the angle world. You are going to see these over and over again. 30 degrees is pi over 6. 90 degrees, a right angle, is pi over 2. 180 is pi. And a full circle, 360 degrees, is 2 pi. You're going to want to get really comfortable with these guys. They're your new best friends. Okay, at this point, you might be thinking, why? Why do we have to learn a whole new system? Is this just to make math harder? No way. Let me show you an example that proves just how powerful and actually easier radians can be. So what if I threw this at you? Find the tangent of 19 pi over 3. Yikes. I mean, your first instinct might be to convert that to degrees, but you'd get a huge number, like 1140 degrees. That's not very helpful. But with radians, there's a super elegant trick. Let's just break this fraction down. 19 pi over 3 is the same thing as 18 pi over 3 plus 1 pi over 3. And what's 18 divided by 3? It's 6. So we have tan of 6 pi plus pi over 3. Now, here's the magic part. Remember how a full circle is 2 pi? That means trig functions just repeat themselves every 2 pi. So 6 pi is just going around the circle 3 times and landing back where you started. It doesn't change anything. So we can literally just ignore the 6 pi. All we have left is tan of pi over 3. And we know from our chart that pi over 3 is just 60 degrees. And tan of 60, that's the square root of 3. See? No big numbers, no calculators needed. Radians just simplified the whole thing.
And that's really the big takeaway here. Radians aren't just a quirky alternative to degrees. They are the actual language of higher math and science. When you get to calculus or physics or engineering, everything that involves circles, waves, or rotations, it's all done in radians. It's the native language. Learning it now is like getting a passport to a whole new world of science.
So you've officially graduated from just thinking about triangles. You're now thinking about the full circle, about endless rotation. You've got the new rules, this powerful new tool for understanding angles. The only question left is, are you ready to play the game?